All right, my name is Jason Ray. I'm really excited to be here giving this presentation today. I think it's going to be a lot of fun and hopefully very interesting as well. I've entitled my presentation, How Does Science Work? The Scientific Method, Drugs, and the News. I want to start off talking about media health claims. If you have ever been on the internet, you've probably seen something like this. When I saw this study, which claimed that many common and dangerous diseases can be caused by eating kale, I was furious. I immediately threw away all 20 pounds of kale that I had in my refrigerator and made a big sign to go protest outside of Whole Foods. Luckily, before I left the house, I started thinking that maybe I was overreacting a little bit. I did some more research, and I found out that this study saying that kale is bad for you was not based on incredibly good science. It turns out kale is just fine. Now, this is maybe a humorous example of science that isn't super solid or that can be falsely reported, and that may seem to cause some controversy. But what about more serious examples of seemingly controversial or confusing science, like the things that we're going to talk about today, such as vaccines and fracking and climate change? Well, I will later in my talk address vaccines and whether or not there is a link between vaccines and autism. But before I get there, I'm going to start off talking about the way that scientists think about questions and solving problems. Next, I'm going to talk about how scientists discover drugs, and I'll illustrate by using two of my favorite stories of drug discovery, penicillin and kaleido. Finally, I'm going to finish off by talking about vaccines and whether or not there's a link between vaccines and autism. So I want to start off talking about Cinderella. You see, the prince in Cinderella had a really cool method for figuring out stuff. You see, the prince started with a question. His question was, who was the beautiful woman that he danced all night with? The prince also had a shoe that Cinderella left behind when she ran away before her coach turned into a pumpkin. And the prince decided to try the shoe on every woman in the entire kingdom until he found the woman that it fit. After he would try the shoe on somebody, he would ask, does it fit? And then he would look more closely and say, no, it didn't fit. He then went back to an earlier point in this process and repeated it over and over again, trying the shoe on more women until he found Cinderella, the woman that the shoe fit. And then they got married and the entire kingdom rejoiced. So scientists are very much like the prince from Cinderella. And I say this because all of us like to dance. No, just kidding. Scientists, like the prince from Cinderella, use the scientific method. Just like the prince, scientists start with a question that they want to answer. The prince had a shoe or something that he wanted to test out. Scientists would call that a hypothesis. The prince tried the shoe on many different women. That sounds an awful lot like an experiment. After trying the shoe on every different woman, the scientists asked if the shoe fit, just like scientists make observations based on their experiments. When the prince noticed that the shoe didn't fit, he was analyzing the results from his experiment, just like scientists analyze the results from their experiments. Just like the prince had to go back and try the shoe on many women before he found Cinderella, scientists often have to go back to an earlier point in the scientific method and maybe come up with a new hypothesis or figure out new experiments to better find answers to the questions they're asking. And just like the prince shared the results from his experiments, when scientists discover something, they share their results as well. Before I go on, I want to zoom in on one word, hypothesis. A hypothesis is the thing that scientists are going to test. But the way that a scientist phrases a hypothesis is, it is something that they're going to try to prove wrong. If a scientist is unable to prove a hypothesis wrong after many, many experiments, then it's taken to be probably true. The more experiments that are unable to disprove a hypothesis, the more likely it is that something is true. Now that we've talked about the scientific method, I want to talk about how the scientific method is used to discover drugs. And I'm going to do it by telling two of my favorite drug stories. The first is penicillin, which was the first antibiotic. To understand why penicillin was so important, you really need to understand what life was like before antibiotics. Before antibiotics, bacteria like this little guy on screen basically ran wild. You could get an infection in a tiny cut in your finger that could end up killing you. Many surgeries that today are safe and routine because of antibiotic use, back then could lead to deadly infections. And many soldiers who were wounded in non-lethal ways still ended up dying because of infections that they acquired from their wounds. Enter Alexander Fleming. Fleming was a professor of bacteriology at St. Mary's College in London. After coming home from vacation one day, he decided to check on some petri dishes that he had set up with some bacteria. A petri dish is a round dish with a cover that scientists often will spread bacteria around in the bottom of. When Alexander Fleming looked at his petri dishes, he realized that one of his petri dishes must have gotten opened and had something spilled in it because there was some mold growing in one corner of the dish. However, Fleming was very interested to notice that in between the bacteria and the mold, there was a space. They weren't growing right up against each other. At this point, Fleming started to use the scientific method. His question was, what's causing that space between the bacteria and the mold? His hypothesis was that the mold was doing something to fight back the bacteria, that the mold was making some molecule that fought the bacteria away from touching up against the mold. Fleming did many experiments and observations and was able to analyze his results and discover that in fact there was a molecule that the mold was producing to fight away the bacteria, and that molecule was penicillin. Fleming and many other scientists then worked together to find a way to produce penicillin in huge vats, in enough quantities that they could use it as a drug. They then shared penicillin with the world as a life-saving medication. Many historians believe that the Allies were able to win World War II in part because they had penicillin and their soldiers were not dying from infections that they got from cuts and scrapes and minor wounds. And that's just part of the reason why penicillin is one of my favorite drugs. It's a really amazing molecule. The next drug story that I want to tell is a drug called Kalydeco. Now, Kalydeco treats a disease called cystic fibrosis. So before I talk about what the drug does, I want to talk about the disease. Cystic fibrosis is all about chloride pumps. That's chloride like sodium chloride or table salt. So you can basically think about these pumps as just moving salt around. Now, what effect does moving salt from one place to another have? Think about what happens after you eat some salty food like potato chips. You immediately become thirsty and want to drink water. The same thing is true for the different parts of your body. If these chloride pumps move salt from one place to another, then that part of your body will start to pull water towards it. In that way, your body can keep water away from places that need to stay dry and towards places that need to stay more hydrated. In cystic fibrosis, these chloride pumps have a mutation that causes them to fail in one of a couple of different ways. Some of the mutations make it so that the chloride pumps crash on the way to arriving where they need to be. They never get delivered and they can never function. Sometimes the chloride pumps arrive at the correct place, but they're slammed shut when they get there. Because these chloride pumps, for whatever reason, don't work, the mucus in the lungs is not hydrated enough. It doesn't have enough water in it, and it becomes really thick and sticky and takes on kind of the consistency of peanut butter. This thick peanut buttery mucus in the lungs has a couple of different effects. It causes a lot of coughing. Thick mucus also causes problems with the pancreas. And that peanut buttery mucus is a great breeding ground for infections, and so it causes CF patients to have problems with their immune systems. As a result, patients with CF have to do hours a day of breathing treatments. Here is a CF patient using a nebulizer to inhale some medications that will go into their lungs and help treat the infections there, and using a vest that shakes and vibrates to loosen up the mucus in the lungs and allow it to be moved out. And this, the person here, the CF patient on the screen, is actually my older sister, Cindy. And she is the reason that Kalydeco is one of my favorite drugs. So the person, or the entity that decided to ask the question that led to Kalydeco was the drug company Vertex. They asked, is there something we can do to help patients with cystic fibrosis? They had a hypothesis that they could do something about the chloride channels that were not working. That maybe just like you can keep open a broken door by sticking a trash can or jamming a shoe underneath it, they could find something to keep open the chloride pumps, or the chloride channels. The experiment that they did goes something like this. They took a tube, and into that tube they put a special type of cells that is one color if the chloride pumps are closed, and another color if they get jammed open. What you can do then is you can take a molecule and insert it into this tube with the special color changing cells. If the color doesn't change, then you know that the chloride pumps are still closed. If the color does change, then the molecule did something and the pumps are now open. Once you can do this in a single tube, it's quite easy to do it in 100 different tubes at the same time. Or you can do what Vertex did and use a facility with robots to test thousands and thousands of different molecules to see if they have the ability to keep open these chloride pumps. Vertex tested over 200,000 different individual molecules before they found one that was able to keep open these chloride pumps. At this point, they, after analyzing it and finding this molecule, they went back and they developed a hypothesis that they could make this into a safe drug, a drug that people could take that wouldn't be harmful to them. In order to confirm that this drug would be safe, they tested it on rats. And if you'd like to know more about why scientists use animals, especially in medical research, then I'd invite you to check out the video for May Science in the News, which is entitled From Molecules to Minds. And they talk a good bit about animal models in that series and why they're used to study disease. But finally, the scientists at Vertex found that this molecule was able to jam open the chloride pumps, just like a trash can could jam open a stuck door. And they shared their discoveries as the drug Kalydeco. Now, Kalydeco, the reason that it's one of my favorite drugs is because my sister was able to have a daughter. That's my niece Kate, who just turned 5 last month. Before Kalydeco, we weren't sure if she was ever going to be able to get pregnant, but because of Kalydeco, she was able to. Now that we've talked about the scientific method, and we've used the scientific method to look at how drugs are discovered, with the example of penicillin and Kalydeco, a couple of my favorite drugs, let's bring it home, and let's talk about how to use the scientific method to evaluate something that you might see while scrolling through Facebook. Something like this. My friend posted an article that she found that stated that infant monkeys that were given standard doses of vaccines developed symptoms of autism. Now, this definitely looks worth investigating because I think it's pretty important to know if vaccines really cause autism, because I want to be able to keep my family safe. I'm going to start out in my scientific method exploration of this question with the hypothesis that vaccines are bad, that they do cause autism. Now remember, I'm going to try to disprove this hypothesis. And that's important, especially when your experiment is plugging something into Google. Because Google is really good at giving you pretty much anything that you want to hear. So if you try to confirm your hypothesis, you'll almost always be able to find things to confirm it. But if you try to disprove your hypothesis, then you'll go through and disprove all of the false hypotheses until you're left with the true one. So I started doing some Google searching, and the first thing that I found was the study that my friend talked about, which showed that when infant monkeys were given vaccines, they developed symptoms of autism. I also found the very first study that ever linked vaccines and autism. But when I looked a little bit deeper into this study, I found something a little bit interesting. This study was retracted. It turns out that the scientist who performed this study, Andrew Wakefield, made up over half of the data. It was completely fabricated. He did this, I later found, because he wanted to be able to sue companies that were making vaccines based on the results for his fake study. Really an evil scientist type, if I say so myself. It turns out that the study that used monkeys to show a link between vaccines and autism also had several issues. For one thing, each of the groups that were administered vaccines only had about 3 monkeys in them. And that's a very small number of monkeys to be able to draw any conclusions about the broader effects of vaccines. To illustrate why this is true, let's say that I'm going to perform an experiment, and the hypothesis in my experiment is that vaccines make people look alike. And I only have 3 people in each of my groups. And in the group that I give my vaccines to, I happen to choose triplets. Now, because the triplets all look alike, I might conclude that vaccines make people look alike, but that's not true. That only happened, that result only appeared because my group was too small. A later study used 4 to 5 times as many monkeys and found that there is no link between vaccines and autism, and that the first study only appeared to show a link because of its faulty construction. At this point, I feel fairly comfortable saying that my friend's Facebook post should probably also be retracted. Both of the studies that we've looked at, both the study using monkeys and the original study that tied vaccines to autism, were either badly constructed and were disproved by later better constructed studies, or were outright fakes. However, I wasn't comfortable at this point with saying that I knew for sure that vaccines didn't cause autism. I had disproved 2 articles saying that they did, but I wasn't completely convinced that there wasn't any evidence out there for the link between vaccines and autism. So I went back and I changed my hypothesis and I did some more Google searching, and at this point I found dozens and dozens of articles and studies showing that there is no link between vaccines and autism. This particular study, which I've highlighted here, used data from over 1 million different children and found that there's no link whatsoever between vaccines and autism. And now I'm here sharing that result with you in a Science in the News talk. Now let's take a look one more time at what we've gone over today. First, we looked at the scientific method and how scientists ask questions to find answers. And we used the scientific method to look at a couple of different examples of drug discovery. Penicillin, the first antibiotic, and Kalydeco, a medication for cystic fibrosis. Finally, we used the scientific method to look at whether or not there's a link between vaccines and autism, and we found that there is no link and that vaccines do not cause autism. Now let's scroll down to your Facebook feed and hear Andrew's talk about fracking. Thank you.